Welcome to Section 12, where we'll be discussing dwarf planets, small bodies, and all the little things left to see inside our solar system. As motivation for this section, we like to bring up these awesome pictures and ask ourselves, why crash into a comet? What will we hope to learn? What are we going to gain from that knowledge? You know the drill by now. Let's have ourselves a little reading quiz and ask, hey, what's the size of a typical asteroid in the asteroid belt? Go ahead and pause. Come right back. And we all should agree that the typical size is about a house. Ceres is going to be one of the largest objects in the asteroid belt, and it's smaller than our moon. So we definitely need to be shrinking down the scale when we're thinking about asteroids out there. For this section, we're going to try and build up the remainder of what is in our solar system outside of the planets and their rings and their moons. And because of that, we're going to end up defining things like dwarf planets and talk about the origins of asteroids, comets, meteorites, and all the interplay relationship between those things. And discuss what kind of impacts this will have on our understanding of our solar system, and related to impacts, what impacts have happened to Earth or any other object in the solar system recently. So putting into perspective the remainder of things in our solar system, let's jump to the asteroid belt, which is about 3 astronomical units away from the sun, and is just riddled with thousands of asteroids. And asteroids are basically just floating debris of rocks and metals. And the total mass of all of these little specks here is about 3% of the moon. It's really not that significant. And one thing that we need to dispel here is that while this image will give this perspective of this very dense filled space, asteroid belt's honestly kind of a void. It's mostly empty. There's no going to be trying to escape the empire by fleeing through the asteroid belt. It's just not that dense. What is that these objects are not very big, and they can have kilometers or more of distances separating even the tiny specks between them. Let's shrink down our last picture here to expand out our view of the solar system. So this box here will be about the edges of Jupiter, where you can see the asteroid belt there, and now we can see the Kuiper belt, about 30 to 50 astronomical units away from the sun. And let's talk about the similar properties. We're seeing, yes, thousands of particles flying around out there. But this time, instead of being rocks and metals, this could be composed of the volatiles. Basically, any kind of substance that, while if you brought it to the Earth, methanes, ammonias, gases, materials like that, you brought it to Earth, it would vaporize immediately, turn to a gas. But because of the distances away from the sun, these things are cold enough that they're frozen solid. And that's why we call them the volatiles. The total mass of all this material will be around 10% of Earth. So we're still not to the size of a moon, but we have a lot more of these particles. And in this space, that's where you're going to find objects like Pluto. But even this is not the edges of our solar system. We still need to go out some. Standing even further out, starting around 2,000 astronomical units to 200,000 astronomical units, will be this Oort cloud. And this is a spherical shell surrounding the entirety of the solar system that is composed of billions of these slow-moving comets. So, looking at this graph in a bit more detail, the numbers here, this is not a linear plot, right? Here's 1 astronomical unit, then 10, then 100, 1,000, 10,000, 100,000, million astronomical units. So each step is an order of magnitude bigger in scale. Trying to put this in proper perspective. And we have Voyager 1, who was just past about 100 astronomical units. And at this region, you'll find what we call the heliopause. And that The heliopause is what we can normally define as the edges of the solar system. The difference, what happens here at the heliopause, is basically the radiant pressure, how much the sun is pushing things outward from just its solar rays, finally reaches a point where it's balanced out by, well, the rest of the universe pushing back at us. At the heliopause, there is this boundary where it's flipping from the sun pushing out to the solar light energy from the universe pushing back. And that's the boundary of this heliopause. And so this is normally what we call the edges of our solar system. Now going beyond that, go to around 63,000 astronomical units away, which is about 1 light year. That's where you're going to find this Oort cloud living. Let's switch to another picture of this, and you can see how this Oort cloud, it really is this spherical shell. The asteroid belt and the Kuiper belt, they tend to be these discs that you can kind of see. Let's kind of highlight this. You can kind of see the disc here. But the Oort cloud itself is literally an entire sphere of material floating around, slowly falling in. And this should remind you of something that we've discussed in previous sections. Think back to the nebulous model. What was it? It was this gigantic gas cloud of dust that eventually collapsed down into a protostar at the center and a accretion disk. The Oort cloud is very likely the remains of the nebulous cloud that eventually collapsed and formed our solar system. Now let's try and categorize all the things that we find in our solar system. And before you start furiously scribbling notes, let's give me a moment, and we're going to reduce this slightly. But I want to emphasize that these are human terms, human terminology. We're trying to group things together, and it doesn't work perfectly. Look, it's crazy. We've got centaurs down here in the smallest solar system bodies, and also a category of centaurs with dwarf planets. What the heck does that mean? So let me reduce this a little bit, and let's just focus on things we have talked about. We've talked about the planets, satellites. That'd be, say, moons. And now we start talking about, in this sections, the dwarf planets and the comets. Plutoids, trans-Neptunian objects, smaller solar system bodies, all these are going to fall into the discussion of this section, where Plutoids are just a subset of the dwarf planets, named after Pluto, of course. Trans-Neptunian objects, this is going to be just a broad category of things that are past Neptune. That's it. Just a range of things that are beyond Neptune. So we're finding that there is a wide variety of material still just floating out in our solar system.